Hi, everybody. Mary here, and we are going to continue practicing balancing chemical equations. So, this talk is all about practice. We're going to go through multiple equations, and I'm going to ask you to hit pause, give a chance, practice balancing the equation, and then we're going to go through them. If you want a warm-up exercise, let's do this one together. If you feel confident, dive right in and balance it, and then we'll go through it and make sure you're on the right track. Okay, we have one calcium, two fluorine. How do I get two fluorine over here? Coefficient. You can only change chemical equations to balance them by adding the big numbers, those coefficients. You cannot, never, ever, ever change the subscripts, because if you do that, you are changing chemistry. You are changing how they bond. You have to only balance with the big coefficients you put in front. If I put two fluorines here, then we go back and look. I have two hydrogens. I look at this and I have one sulfate and I have one sulfate, SO4, and I think I'm done. That is balanced. So that reaction, the entire reaction, is balanced. Sometimes you don't need a long song and dance. You just need to add perhaps one small number and you're good. Now remember, I'm adding hints as we go along. Now hints are not rules, they are just hints. They're more like guidelines instead of rules, just like we're on the Black Pearl. So they might help you, they may not. Balancing is an art sometimes more than something very systematic. So you definitely do what works for you. I find using a pencil very helpful because I make errors. So give this one a shot. Alrighty, aluminum. I've got one aluminum, two here. I'm going to put two aluminum there, two hydrogen. I've got three sulfates, one sulfate. I am going to increase that to three. Now I've got six hydrogen. How do I get six hydrogen over here? Add a three to that. So two aluminum, three sulfate, 2 times 3, 6 hydrogen, 2 times 3, 6 hydrogen, and I am good. You'll notice that I've been balancing my polyatomic sulfates as whole entities. You don't have to do that, and sometimes you can't because they break apart in the reaction. I'm a little bit lazy, and so I like to treat a polyatomic ion as a whole entity if it sticks together as a whole entity. Try balancing this one. Alrighty. Now, I've been balancing starting at the left. There's no rule that says you have to start at the left. You can start anywhere your little heart desires. And for giggles, I am going to start way the heck over here with hydrogen. Why? Because I want to. I've got two hydrogen. And so how am I going to get two hydrogen over here? I'm going to put a big 2 there. Two hydrogen. Then I'm going to go to oxygen. I've got two oxygen. Whoops, I've got one oxygen here and another oxygen, so I've got two oxygens. How many oxygens on this side? Two oxygens on that side. How many sodiums? Two sodiums, 1, 2, two sodiums on that side. Two chlorines and another 1, 2 chlorine on that side, and we are balanced. This is chlorine plus sodium hypochlorite, sodium hydroxide aqueous, yield sodium hypochlorite aqueous plus sodium chloride aqueous plus liquid water. Sodium hypochlorite is the active ingredient in common household bleach. By regulation, regular household bleach is 5.25% sodium hypochlorite. If you get some sort of a mega extra strength bleach, it can be up to 6% sodium hypochlorite, but it doesn't matter brand to brand, the active ingredient and the concentrations are pretty much the same. Another hint that may be helpful sometime, and I use this a lot, and that is to look for the least common multiple. If you were dealing with larger or awkward numbers. So go ahead, hit pause, give this one a try. Okay, potassium chlorate decomposes into potassium perchlorate and potassium chloride. Now this hint, look for the least common multiple. Here's what I've got going on. I got 4 oxygens here and 3 oxygens here. That's going to be kind of a pill. But I know that 3 times 4 give me 12. So I'm going to dive right in and aim for 12 oxygens. So I'm going to multiply this times 3, this times 4. 3 times 4, I'm going to have 12 oxygens on that side. 3 times 4, I'm going to have 12 oxygens on that side. Now let's look at the other elements involved. I'm going to have 4 potassiums. What have I got on this side? I've got 3 potassiums plus 1 more potassium. I've got 4 spread out here and there. Chlorines, I've got 4 chlorines, and on this side 3 chlorines plus another 1 chlorine is going to give me 4 chlorines. So this matches this matches that, my oxygens match. Yahoo! I balance. Here's another hint. Balance other elements and leave oxygen until last. Now remember, they're hints. They don't always work in all situations. And here I said leave oxygen to the last. The last one, I balanced oxygen first. And you might be giving me the, what gives, Mary? Look, and you're allowed to do that. Like I said, balancing, you just kind of jump in, do what works, and see what happens. This time, I'm going to balance everything but oxygen and leave that to the last. So hit pause, give it a try. Okay, here goes. I've got 4 phosphorus, 2 here. I'm going to multiply by 2. So now I have 4 phosphorus on that side, and I have 4 phosphorus on this side. Hydrogens, I've got 2 hydrogens on this side, but 2 times 4, I've got 8 hydrogens. How do I get 8 hydrogens over there? Multiplied by 4. 2 times 4, 8 hydrogens. So those are good, and those are good. Let's look at my oxygens. 2 times 7, holy buckets, that's 14 oxygens. On this side, I've got 10 oxygens plus another 4 times everything behind it, plus 4 oxygens. That means I've got 14 oxygens. Hoo-hoo, those balance, we are good. And these chemicals, let's take a moment and say them. This is tetraphosphorus. Tetra, remember, is 4. Tetraphosphorus decaoxide. Deca means 10. Plus liquid water yield pyrophosphoric acid. This is not a common acid. Not terribly useful in a lot of industrial applications, but it's really fun to bond. All right, hit pause, give this one a try. Now, if you have truly given this one a try, your face right around now is going, ah! And the reason is because as it sits, it will not balance. And why did I do this to you? Well, I gave this to you because it's going to happen, especially with reactions that you personally write. If it will not balance, no matter what has happened, check that it has been bonded correctly. Check that it has been copied down correctly. If you are copying down something from homework, maybe you just forgot to write down a subscript. Personally, this is me. I have looked like that for hours of my life trying to balance equations that will not balance. And so make sure that you're doing it correctly. And it's things that, yeah, the chemistry's wrong, it won't balance. Nature is always right. And we humans are the ones that make boo-boos. So can you spot the bonding error? Sodium has an ionic charge of +1. Sulfate, SO4, is a -2. When you crisscross, that should go down there. So it should be Na2SO4. If you now want to hit pause and give it a shout, try it. All right, here we go. Now it's pretty easy. A 2 goes here, a 2 goes there, and now it will balance. Whew. Last but not least, when you balance a chemical reaction, you must reduce it to its lowest form, because remember these equations, we are trying to represent what nature is going to do. And nature is always going to use the minimum number of atoms and molecules in any sort of reaction. And that's what we're trying to represent by a chemical equation. So if you have an equation like this, and in your flurry of excitement balancing, you end up with something like this, and you step back and you look at it and you go, 2, 6, 4. It balances, but every one of the coefficients can be divided by 2. In its current state, it is wrong, and you have to reduce it to its lowest form before it is correct. So this must be reduced to N2 plus 3H2 to yield 2NH3 ammonia. So you must reduce it down to that lowest form. This is correct. And as it sat up here, this was not correct. Right. Now take a moment and see if you can reduce this one to its lowest form. Alrighty, this 4, 2, 4, everything should be divided by 2. This becomes a 2, this disappears, and that becomes a 2. Now it is a correctly balanced chemical equation. And that should do it, my friend. And we will see you later. Okay, bye-bye.